Hello, today we are covering lesson 6.6, trapezoids and kites. You guys will be able to understand and apply properties of both of these. We have new vocab: trapezoid, bases, legs of a trapezoid, base angles, isosceles trapezoid, mid-segment of a trapezoid, and kite. So the properties of a trapezoid states a trapezoid is a quadrilateral with exactly one pair of parallel sides, only one pair, not two pairs like a parallelogram. So a trapezoid is not a parallelogram, is what that is saying. The parallel sides are called the bases. So whether they are horizontal like here or vertical over here, these are considered the bases because they are the parallel sides. The non-parallel sides are called the legs. The base angles are formed by the base and one of the legs. In trapezoid A, B, C, D, A and B are one pair of base angles, and angle C and angle D are the other pair of base angles. If the legs of the trapezoid are congruent, then it is an isosceles trapezoid. So this one is not, but if they were, it'd be an isosceles trapezoid, and we have some theorems about isosceles trapezoids. If you recall from isosceles triangles, some of these should make a lot of sense. If a trapezoid is isosceles, then each pair of base angles is congruent. So if you were to extend this trapezoid into a triangle, we would know that these sides are congruent, then the base angles are congruent. So you can keep that idea in mind when talking about isosceles trapezoids. So the base angles G and H are congruent, and the base angles F and J are congruent to their pairs, okay? Now, to know which ones are congruent to which, it is the angles formed with the base between them. Angles formed but still has the base parallel between them, okay? We also know then, based on that any consecutive non-congruent angles, so one each from the bases, add and equal 180. We'll need that in a little bit. Another theorem we have is if a trapezoid has one pair of congruent bases, then it is an isosceles trapezoid. Also similar to the triangle idea, if these guys are congruent, the base angles are congruent, then the sides are congruent. And then we know that a trapezoid is isosceles if and only if its diagonals are congruent. So if you recall, like I said earlier, rectangles, like the rectangle slideshow, tells us that rectangles have congruent diagonals. Well, trapezoids do too. That's why when we were talking about rectangles, we first had to know it was a parallelogram. If it's not a parallelogram, it's probably a trapezoid with congruent diagonals. So let's use this information. Notice there's a little typo here. I already fixed it. So each side of the basket is shown an isosceles trapezoid. So we know all the things above. We know that JML is 130 degrees. We are trying to find MJK. So we talked above the consecutive sides that are not congruent to each other, so like M and L are congruent to each other, and J and angle K are congruent to each other. The non-congruent sides add and equal 180. So to solve for angle MJK, you just subtract 130 from 180, and you end up getting 50 degrees. Then the one that had a little bit of a typo, we know that KN is 6.7, and we know that MN is 3.6. If we are trying to find JL, well, the diagonals are congruent, so simply add the two pieces we know, and we get that JL is equal to 10.3 feet. Okay. The next one's very similar. We'll go ahead and look through it. Once again, the basket is shown. It's an isosceles trapezoid. We need to know that. That means these are congruent and these guys are parallel. We know that FGH, whoopsie, we want this one, FGH is 124 degrees. We are trying to find EFG. Same thing here, consecutive angles that are not congruent, are not a base angle pair. You just subtract from 180 to solve. So 180 minus 124 is equal to 56 degrees. And then for IH, this one is a little different than the previous problem. IH, we know that FI is 9.8. We know that IG is 4.3. Now, we are trying to find this thing. So you can just go ahead and say that IH is also 4.3 feet because IG is 4.3 feet. Now we are going to talk about the mid-segment of a trapezoid. This is the segment that connects the midpoints of the legs of the trapezoid. So from your legs, you take the midpoints. That cuts each leg into two congruent pieces. The mid-segment runs parallel with the two parallel sides, and we know something special about it based on this theorem. The mid-segment of a trapezoid is parallel to each base, and its measure is 1/2 the sum of the lengths of the bases. Basically, you're taking the average of the two bases, so AF plus CD divided by 2 equals the mid-segment. So in the figure, MN is the mid-segment of trapezoid FGJK. What is the value of X? Now this is a little different. You already have your mid-segment given to you, so this is what the whole thing will equal. We're trying to find X. You take 20 plus X and divide that by 2 to figure out what X is. So we go ahead and solve. We multiply 2 on both sides to get rid of the denominator of 2. We have 20 plus X equals 60. And then we go ahead and subtract on both sides to get X equals 40. Some of you guys might have saw that this has a difference of 10 between them. So then you'd probably be like, well, this one probably also needs to have a difference of 10, or adding 10. So X should equal 40. Notice that is the same thing that we got doing it with algebra. So now we're going to do the same thing here, except we have to write things out. Notice these are just labeling the angles, nothing that has to do with this particular problem. We have WXYZ as an isosceles trapezoid with this mid-segment JK. So XY, we're going to find, so give it a variable. JK is 18, and WZ is 25. So we are going to go ahead and then solve for X. Notice once again we are given the mid-segment, so that's what the whole thing ends up equaling. So you have 25 plus X divided by 2, it's just the average. Solve for X, so you have 25 plus X equals 36. Finish solving, and X will equal 11. If you did it the other way, you notice that you have a difference of 7 here, which would get you the same answer for the length of XV. We could probably mark it there too. Now we are going to move on to properties of kites. A kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. Recall, rhombuses have all sides congruent, but they also have consecutive congruent sides. So once again, we had to know a rhombus was first a parallelogram before we could say it was a rhombus, because maybe it could have been a kite. So unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. It's none of those things. I want to point out real quick that a kite is made up of 2 isosceles triangles. You have this triangle here, and you have the second one over here. If you recall from isosceles triangles, the base angles are congruent to each other. So that means we have our theorem here, our 6.26, that these, where the two isosceles triangles come together and share a side are congruent angles. So in this case, angle J and angle L are congruent because that is where the two triangles come together and meet. We also know, I kind of skipped over 6.25, that also like a rhombus, their diagonals their diagonals come in and are perpendicular to each other. That means we can do a lot of Pythagorean theorem if we need to. So we have this kite, WXYZ. We are going to find the measure of angle XYZ, this guy. So if you recall where the two triangles come together, those two angles are congruent to each other. So we know angle Z is 121. We know all quadrilaterals' interior angles add to 360. So we can take 73 plus 121 plus 121 plus the measure of angle XYZ has to equal 360 degrees. We can go ahead and add these, so we get 315 equals the measure of angle XYZ, and then solve for the measure of angle XYZ. Equals 45 degrees. And then if this is also a kite, we're going to find NP. Notice this is a perpendicular here. We can do Pythagorean theorem. So we can actually find MN, which is congruent to NP that we want to find. So we are going to take 8 squared plus 6 squared equals NM squared or C squared. I don't really care what you call it. So 64 plus 36 equals MN squared, so 100 equals mn squared, and take the square root. So mn is 10, that means np is also 10 because they are congruent to each other. And then if BCDE is a kite, find the measure of angle CDE. These are very similar to the last ones. We're trying to find this one. So you go ahead and add those up. And then subtract them from 180. So we get 300. Oh, sorry, don't subtract them from 180. That would be silly. Subtract them from 360. We are working with quadrilaterals, not triangles. My bad. Just comes out of my mouth so easy now. We do it a lot, don't we? So the measure of angle CDE is equal to 36 degrees. There we go. And then same thing as that last one, we can use Pythagorean theorem to find JK, which is the same as KL. And this one, like the last one, turns out to be a perfect square. So that's nice for us. So KL is also equal to 5 because KJ is equal to 5. And we have our final two solutions. Alrighty, have a great afternoon.